Okay, the clock says 1:20, so I'm going to go ahead and get started. I should first say thank you. I know that I'm a weird wild card at this conference. I'm not talking about C# or the Java virtual machine. I'm talking about something really weird and kind of abstract. So thank you for taking a risk with the scheduling to come here and hear me talk about this semi-hypothetical future. So just to make sure everyone's in the right space, I'm here to talk about the dawn of a new type of technology that I think I've identified, that I'm rescuing an old English word for, Agentive. And the subtitle that wasn't in the materials is the UX of narrow AI. So a little bit about who is up here on stage talking to you. That's my name. You can follow me at Twitter there. I was actually here last year. I am most recently a co-author of the 4th edition of About Face, a big textbook on how to do interaction design or interface design. But before that, I was co-author of a book called Make It So that took a look at interfaces in science fiction, where I currently blog at sci-fi-interfaces.com. And in fact, I got to Øredev last year because I was talking about that weird subtopic interest of mine, but you can go there at Sci-Fi Interfaces. The thing I'm talking to you today about, what ended up being inspired by what I saw in science fiction, but was actually quite about the real world. In my day job, I am an interaction designer, so I work with developers and developers at client organizations in order to create software and applications. Cooper's in San Francisco, and we just opened up an office in New York City, so we're now bi-coastal in the US. Our claim to fame is probably that Alan Cooper wrote the first book that made the case for letting designers have a big seat at the table for software development. And today we do things like create apps. Our most famous app is probably TaskRabbit. And we also do classes like Cooper U, where we teach interaction design all over the world. All right, so that's a little bit about who I am up here. And I failed to start my stopwatch. I'm going to do that now. So if that's who is up here, let me tell you a little bit more about what I'm here to talk to you about. And that's this notion of narrow AI. Now, that's a term of art that I'm going to spend a little bit of time talking about. When folks talk about artificial intelligence nowadays, typically they're talking about a very particular subset of artificial intelligence. Either they're talking about an artificial intelligence that is very similar to humans in that it is a general problem solver, and that category of artificial intelligence is called AGI, Artificial General Intelligence. The one that most people are afraid of is the one that comes after that, which is artificial superintelligence. It's that one that is defined as being evolutionary, where the artificial intelligence can actually make a refined copy of itself. And that's supposedly past the singularity, where we don't know what on earth our future is going to look like. Those are two genuinely problematic versions of AI. There's lots of cultural conversations to have about that. There's lots of ethical conversations to have about that. But I'm a pragmatic fellow. I'm interested in the stuff that comes before that. There's a category of artificial intelligence called artificial narrow intelligence, and that's where it's not a general problem solver. You can't ask it to do your homework. You can ask it to do a very specific task. ANI is the shorthand for that. And it's the type of technology that I'm most interested in because it's happening now. Part of my talk today will be to make the case for the fact that it's not only happening now, but it's also a threshold technology that once you get there, you can't look back, and that the time is right for developing a community of practice in order to do this well. So that's what I mean when I talk about narrow AI. And as an example, I want to just share with you one of the greatest examples of this technology that I have come across. Has anyone here ever used the narrative camera? A couple of hands are raised. So for the rest of you, I'll go ahead and describe what this beautiful device does. It's actually founded here in Sweden, so you guys can be really proud of this. And I tried to get them to come and be part of this talk, but they were very busy with their startup. But the narrative camera is a cool device. Looks like this. It's maybe a decimeter. It's probably a bit, maybe half a decimeter on a side and a square. And it has a clip on the back, and it has a light sensor and a lens on the front. They're just about to release their second version of the camera. And it works like this. You charge it up, and then the minute you unplug it, it takes a look and see, is there light in front of the camera? And as long as the answer to that is yes, it takes a picture about once every 15 seconds, constantly throughout the day. So you can clip it on your shirt or your belt or your backpack and just go about your daily life, and it constantly takes pictures. You can interrupt it if you want to. You can double tap it, and it will take a picture in that moment. But otherwise, it just goes about doing its business. Then when you get home to a Wi-Fi that it recognizes, it uploads all of the images that it has taken throughout the day and uses some fairly sophisticated algorithms to say, okay, it looks like this is when you were at breakfast. This is when you were on your commute. This is when you were at work. This is when you were at drinks. And then it tries to find, using secondary algorithms, the best, most representative image of that chunk of photos. So here's their desktop AI, right? And this is not mine. I'll show that tomorrow if you want to see my narrative stream. But this is somebody else's from 24 May. Here are some of the best photos that the app has picked. And then you, as the user, can say, yeah, that one looks great. That represents the great drinks I had out with friends. I'll annotate that and share it off to social media. And even though you're not actually picking up a camera and framing pictures with it, the results are mostly pretty good, partially by just the law of numbers. If you take 100 photos over the course of drinks, one of those is likely going to be fun. And these are some example photos that the users of the narrative camera have posted and shared that they sort of really love, including like, pics of someone's kids, a horse eye, and then sort of, they're still using their digital camera in this one, which I really love. But they're taking a landscape photo that the narrative got. So this is a really, really interesting bit of technology. And it's weird to call it a camera, but that's what it is. The reason it's weird to call it a camera is that nobody's touching a shutter here. So how is this a camera in the typical way that we think of it? Well, in order to answer that question, I'm going to go way back in time to talk about the problem of image acquisition by humans. It's a problem that we've had for a long, long time. How do we best represent images that our eyes see in the world? The first recorded instance we have of something called the Camera Obscura goes back to the 3rd century before the Common Era. And it was invented like the calculus in 2 places at once. In China, there was a philosopher by the name of Mozi who invented or described something like a camera obscura. We don't have pictures of what he was talking about, but he talked about it. And similarly, Aristotle talked about something like a camera obscura. We don't really get a good diagram and a great picture of what a camera obscura is until Da Vinci in his Codex Atlanticus. But it's simply this principle. Inside of a room, you pierce a hole in the wall, and the light from the outside passes through that hole and shows up as a upside-down image and reversed image on the opposite wall. Then an artist can hang a sheet of paper there, trace the image that they see, and then take that outside, turn it right side up, and suddenly you've got a photoreal image. That was how we had to do image acquisition from the 3rd century before the Common Era all the way up to the 1500s. This was a pretty popular way to acquire images, photorealistic images, for about 200 years. When we realized that, that we don't have to dedicate an entire room to this procedure, we can actually miniaturize it to get to a table. Here's a picture from the 17th century that shows a camera obscura that fit on a table. It was portable. And in this case, the artist has a glass pane and a box. So the artist could put tracing paper over the top of this glass pane and then use an actual lens in order to get the light from outside up against a mirror and onto this surface where he could trace and not have to have a wall-sized image in order to work with. Same principle, but getting miniaturized. This tabletop box kept getting smaller and smaller, and especially with the advent of wet plate photographic technology, on about the late 18th century with daguerreotypes and something called calotypes, we were able to make it small enough that you could actually carry it around. In fact, I think it was 1898 or 1888 that Kodak first developed the thing that it could be carried around. It was called the Kodak. So that same Camera Obscura is being sort of reduced to a size that can be carried around. They invented the Brownie box in 1910, which is very similar to this thing. It's just a little box that you could pick up and carry around with you. That same technology kept getting a little bit better and better. We developed dry plate technology. We added electronics to it. Eventually, we would get to instantaneous photography on about the 1970s. And it was in 1970 that the first patent was given for a digital camera as well. Essentially the same thing as the Camera Obscura, but taking advantage of single lens reflex technology, as well as, of course, all the benefits that computers can give you. But in addition to miniaturizing that giant box and all of the features that we had seen in cameras since the 1910s, it was also able to give you a lot of information about the photo that you were taking at the time that you were doing it. Of course, they had this in analog cameras as well, single lens reflexes, but here was a lot richer, right? If you're looking through the viewfinder of my DSLR, that's the one I currently own, it'll tell you everything about where is the camera currently going to focus for its autofocus. Do you have the flash on? How long will the aperture stay open? How wide is the aperture at this moment? And even, does the camera think this is going to be a good picture? So that's kind of a really broad history of pictures, of image acquisition, until we get to the narrative. And the narrative is massively different, right? If before, the question was always, well, how do I, as an image acquirer, take the image out there in the world and get it to something that I can then hold in my hand and observe? The narrative does the opposite. The narrative says, you don't want to take good pictures, you just want good pictures. So let me help you do that. And that's a fundamental break. And in fact, you can investigate this entire history of this one chain of human need, image acquisition, through a very particular technology lens, which is the question, what work is the tool doing? And in answering this, I think I've come up with sort of 4 categories that you can think about technology. The first things, the Camera Obscuras, were representative of a category of tech that's just manual, right? It shapes the physical forces that you apply to it. So in the case of the first Camera Obscura, there's a physical force, the physics of light. You can poke a hole in there and then use your body to hang up a sheet of paper, use your body to grab a pencil or a pen, use your body to scribe that thing and pull it out. In the second Camera Obscura, same thing, but now you've got to manually sort of pick up this little wooden flap that you can put your piece of paper on and move your body around. And that tool is all about shaping those physical forces in a way that is useful to you. The canonical sort of example of this is just a physical tool, the hammer, which also shapes the physical forces that you apply to it with your muscles and your skeleton. The second one, which is on about the Kodak forward, is where tools can begin to, or in this case, it's from the Kodak forward, where tools begin to supply the power for you. So you no longer necessarily have to use as much of your muscle. You can actually use circuits of power. And I'm using that in a very broad term, not just the electrical term. Windmills use wind as the circuit of power. Water mills use water as the circuit of power. And all those types of tools build up a big system that you can then tap into. The miller pulls a lever, and suddenly they're able to grind wheat. It's a lot easier than having to push that same mill wheel with your hands. So powered tools are doing a lot of the work for you, much more so than the manual tool. But then there's a third category, and honestly, in the image acquisition example, the camera example, that third example might be the first SLR cameras that came on about 1928. And I like to think of those as assistive. If the first two are helping you with physical work, this third category is helping you with the information work of a task, which is it's adding information to help you get the task done. In the case of writing, our manual tools might have been pencils or pens. When it became powered, they might have been typewriters. And we didn't get to assistive technology in writing until we got to spell check and grammar help. Assistive technologies can just tell you about the information you need to know, but they also know the rules by which the task should be done and can help you when you are violating those rules. In the case of my DSLR, it actually tells me when the amount of light given my settings is going to peak out the blacks or peak out the whites, and it gives me a little alarm. It says you need to reconsider your settings for the given photo you're about to take. And that assists me in taking that photo really, really well. But this fourth category is the one that the narrative represents, and that's really fascinating to me because the agentive does the work for you. Now, of course, the narrative camera has some settings to it, and the user, as the user of it, I am a curator of this technology, or sorry, I'm a curator of the end results, but I'm not doing the work, I'm not taking the picture, and that's really, really interesting. So if these are four categories of technology, especially as it regards how much work the users are doing in order to get the thing they want. You might argue just from the couple of examples that I've given you that, oh, well, you're just hand-picking from the history of technology. But I assure you that that's not the case, that there are a whole lot of examples that I have found that are showing that this trend from manual to powered to assistive to agentive shows up in a lot of places. In messaging between humans, we get all the way through, carrier pigeons, and letter writing, all the way to email, and most recently, you can use both mail merge technologies in order to send out mail on your behalf, and also spam filters, which act as an agent in order to catch that crappy spam that ends up messing up your inbox. eBay is a manual tool, partially assistive too, because it can sort of help you know where the bid's going to land. But if you've ever used eBay watch lists, you can actually say, hey, anytime you see a Ted Baker shirt in my size for under $50, go ahead and place a bid on it. And it will constantly sit there and make sure that it bids on my behalf for the shirt that I've told it that I'm interested in. So that's an agent. It's like a shopping agent that you can leave on eBay running. And it'll tell you when it's made that bid so you can resend it. Does anyone own a Roomba in the room? You've got an Agentive vacuum cleaner. It's not like done like Dyson, where it's actually made a really good vacuum for you to push around that's lightweight or easy, or that has a great light in the front and a hand pedal or a foot pedal. It's actually just a device that makes sure you have clean floors. So it's an agent for clean floors. In full disclosure, I'm working on this product. Schwab is a giant financial firm, and they wanted to help their users who can't afford a financial planner or an investment manager use a robot in order to do those two things. So the intelligent portfolio will do a number of things for you. You can throw some money at it and say, this is my risk tolerance. This is what I hope to get out of this investment. And on a daily basis, the intelligent portfolio will rebalance your portfolio and try and help you get to that goal, whatever it is. And the financial planner aspect of it is like, okay, well, we're all trying to build up some savings. Well, what do we do with that savings? How do we get mostly towards retirement or any of the other financial goals that we have? And the intelligent portfolio acts as an agent for that money. You put it in, you tell it what you want it to do, and just let it run. There's an entire thread about the history of temperature management for humans. Right? The manual tools for that might be fans. They might be a window. It might be water spritzing in your face. All of those sorts of things were manual tools until we got to thermostats, which use a feedback loop system in order to maintain the heat and temperature in a given room. You even got to Honeywell, where they're trying to, as of the early 1900s, tell you a little bit about not just what you feel the temperature is, but it actually gave you a readout on what the current temperature is. And then we pass into an agent like the Nest, which says, you know what? You and I are going to have a dialogue, and then over the next lifetime, I'm going to try and keep you as comfortable as I think you intend, as you want to be. So the Nest is an agent for temperature control. Waze is a wayfinding device. You say, hey, I'm at home, I'm traveling to this destination. And of course, on the one hand, that's just a mapper. But Waze as an app is pretty smart. If it finds out that there's a traffic accident that occurs on your route, it will reroute you on the way. A lot of mapping tools do that, just using Waze as an example. But in that way, it's actually a traffic agent. It's not just saying, here's the map, good luck with that. It's saying, I'll keep an eye on things and make sure that you can get where you're going every step of the way. I'll reconfigure on whether we need to rethink what we're doing. And the last one, probably the most abstract, is the if this then that platform. If you've not used it, it's a service that lives in the web where you can simply say, if this event occurs, then do that. Programmers should be wildly familiar with that construction. But they tried to make it super easy for anyone to use. If you tweet the word Agentive, I will add you to an Agentive, I will add you to a list of Twitterers about Agentive technology so that I have somebody that I can talk to about any of these crazy ideas. But the if this and then that is the ultimate abstraction, right? It's the agent of whatever you tell it to do. Hey, agent, when this happens, do that thing. And they can get fairly complicated. Not as complicated as certainly as code can get, but it's close. So these are only 7 examples, plus the camera is an 8th. But just I want to show you that this evolution of product or human problems that advance across tools until we can get them to an agentive state is a common pattern. And in fact, I believe, like Pete Singer calls, certain technologies as threshold technologies, which those are techs that once you get past them, you can't go back. Since I've begun thinking in terms of the agent, every new client that comes to me from Cooper, I'm like, oh, well, we could solve this with an agent, but I don't think you're ready for that yet. So let's talk you through like an assistive technology first, and then I'll mention the agent and see if we can actually get there. So the first part of my talk is that, to simply assert that I believe there's a new category of technology and that there are a number of patterns about it. Let's talk just very briefly about, okay, well, if agentive tech is its own category, what makes it distinct? I'm writing a book on this, so I tried my hand at it. Agentive tech is a narrow or low-level artificial intelligence that acts as an agent on a user's behalf to accomplish some task. That's super dry, and of course you could have inferred that from what I talked about before. What's really most interesting is the list of things, the asterisk thing that comes after it. And I list these out partially because if you believe with me and you'd like your technology or your product or the strategies that you consult on, here are the things to think about when you're designing or specifying an agent. The first thing that is an agent does its work over a span of time. If it's in real time, it's like right now, I wouldn't consider that an agent. Sure, it can be a narrow artificial intelligence, but the agent is something that you can set and go away from, and it will do its work. Of course, in order to do what it does, it has to monitor some data stream to look for that event, to look for that data threshold that it can say, oh, now I see that we have matched item up for bid. It is a Ted Baker shirt. It is a medium, and it is under $50. OK, now I can go ahead and cast the bid with the preferences that you have set. That data stream is where it gets its triggers, and thereafter it follows rules and exceptions. So I could tell it, oh, if the eBay watch list, I could say, if it's green, don't buy it for me. I don't look good in green. It's actually quite the opposite. I look great in green, but you could set up that exception in order to modify the rule. Again, very familiar to developers, but it's getting to the popular users, common users. And so we're going to have to start thinking about how they understand that interplay between rules and exceptions. Over the course of the agent's life, it of course lets you monitor what's happening, how's it going, and play ideally, which is to say, I know that you're doing that thing, that's cool, but let me get in there and play as well. For instance, on the eBay Watcher, you don't set it up and then it doesn't shut eBay. It says you can still look around. You can find something that's been miscategorized. You could try and beat the system. You could discover that you like some shirt other than Ted Baker. Agents contact you with the results and problems. If they are off doing work, just like a sort of a good assistant, they're going to come up and say, hey, I think this is a Ted Baker. I'm not sure. It's spelled Ted Baker without an E. Is that right? Or problems. Hey, you've lost this bid, and it's right in your sweet spot. And there are 2 bonuses that I would say would be sort of like advanced agents. The first is, of course, machine learning, that it learns from your behavior so that you don't have to manually correct it as you go. And the second one is that rather than just taking care of tasks, it attends to goals. The eBay Watcher example that I've used through this list is pretty good about getting me one shirt. But you could imagine that an agent could be written to make sure I have a great wardrobe that not only finds shirts, but pants that match, that are in fashion, that get rid of my old schlubby clothes. Those goals are more valuable to me as a human than the tasks are as well. So advanced agents will be attending to those higher order goals. like image acquisition instead of taking a picture. And if we're looking for a mental model for what an agent is, given these definitions and these things, we know it's not a tool. It's not a manual tool. And in fact, if you think about it very briefly, a butler seems like it might be the right metaphor. Problem with a butler is it's human, not this one. But a butler is generally human. They're going to get tired. They need to sleep. They need to eat as well as you do. So a second metaphor is a robot butler, like Rosie from the Jetsons. But that's still a little bit wrong. Agents aren't necessarily tied to objects. In the case of the Roomba, they are. But if you imagine a medical agent that lives on your phone but then hops over to your physician's computer when you're in her office, it doesn't necessarily need to be tied to a particular device. And in fact, I would argue that the best agent isn't tied to a device, but lives in the clouds and just knows the best device to contact you at any given time. And for that, we need a different metaphor. And I would go all the way back to Middle Eastern mythology. I believe the genie, the jinn, not the Disney version, of course, but the jinn is probably the right metaphor for thinking about agentive technology as we move forward. And just because I love cyanide and happiness, I'm going to show you the entire panel here while I take a quick drink. Okay. So when we take a look at what the tool is doing, we find that Agentive is a really distinct category of tech, and that it is really useful. I'm now going to go to the second to last part of my talk and just say, okay, well, how do we think about this? What's the model we can use to actually pursue this unique category? And first, I'd like to start by introducing you to a model that I don't know that you're familiar with unless you do interaction design. If you are a user-centered designer like myself, you're going to be familiar with this model. This is called the See, Think, Do model. And in it, there's a user on the left and a piece of technology on the right. And when we think about how a user is going through a particular task or a goal, we always describe it in, well, what do they see? What do they think as a result? And then what do they do to correct that result or move the process forward? It's super simple, but all of our scenarios are written out this way. Structurally, this is how we think and talk about the work that we do. I'm talking to a conference where most folks are developers, so we need to acknowledge that there is another half of this diagram. And that's similarly very foundational, right? Whatever the user does becomes an event that counts as input that goes through a function that then changes the output so that they can go. This butterfly diagram is a pretty fair description of all interactions between humans and computers. And as you can see, I've done a little bit of color coding. The human in this is red, and the computer is blue. Which leads us to a model for agents. If we're sticking to the red and blue, then humans will have a very strong amount, have a lot of work to do at the very beginning of their interaction with an agent in order to set it up and say, I have this task or I have this goal. Here are my preferences. Here are the rules. Here's the exceptions. And thereafter, the agent is meant to take over. And it actually takes over that think, do, see loop, but on behalf of its users, saying, okay, well, I'm seeing something. I know the rules and exceptions, and now I'm going to do that thing on your behalf. Of course, in the background, we have to have a computer system that it is commanding or controlling, but since it's working for the user, I'm still going to call it the see, think, do loop. So given this model, we now have a structure by which we can think about the use cases that we need to get right for an agent to work well. Setup and disengage are the two other parts of this bow tie diagram. So during the setup, there's certainly the conveying a capability. When you think about an agent, it's almost like a DOS prompt. If it's sitting out there in the world, how do you know what it can do for you? How do you know that an eBay can actually watch for a shirt? How do you know what that circle on the ground does? Oh, it's a vacuum cleaner, but you need to be told that. It has to tell you somehow that it's got a capability that you as a user are interested in. Especially while agents are a new thing and we're just starting to use them, understanding them by trialing them, saying, okay, I want to play with some money in this Schwab Intelligent portfolio, but I really don't want to use real money. I want to use fake money to see what this thing does and whether it's worth my time and money. So seeing what it can do, like a bike with training wheels, is one use case. Another, of course, is setting those rules and expectations. And there are three ways that we can do this. There's, of course, a manual way, where the system can just ask you, hey, what kind of shirts do you like? What kind of bid do you want? Tell me all the parameters that you like and the exceptions that you can think of, and I'll go from there. A second one is just by watching you. Nest does this, where it says, okay, it was spring. We had you at a little bit above room temperature, and you came and you turned it down. I'll remember that for next year. It's watching those patterns that you're still sort of saying implicitly what it is that you want. And of course, that can go pretty broad. Agents can go and watch your social media in order to understand what your political leanings are. And then news agents can say, oh, I will go grab similar or news items that you will find of interest. That may sound familiar with like Facebook that tries to gauge what the things are that you like in order to organize the things that it shows you, for better or for worse. And the last thing, of course, is listening to you as you use a product, as you correct it. It will try and remember that for the future. So understanding what those goals are, both from a tacit and an implicit level, is going to be a use case that we have to master. And then once all that's done, we've got to start. We've got to launch the thing and let it go. Of course, we still need to be able to control that thing if there are going to be exception cases as you live your life. So the suspension and restart of an agent is going to be an issue. If it's off and running, how do I remember that it's running? How does it know that I'm on vacation? How does it know that I'm like absolutely broke right now and can't afford you to make any bids on any Ted Baker shirt? It's a question we have to resolve. So if that's the setup, there's going to be a lot of use cases around that, and it makes a lot of sense. As the agent is doing its thing during that C loop, it's got a couple of other use cases that we have to take account for. I've already mentioned monitoring, so that's no big surprise. But how do I check in and see that you're still running, you're still doing that thing that I'm hiring you for? But there are also interruptions. How does it come and say, hey, I know you like Ted Baker, but have you ever considered this brand of shirt? Those suggestions are a use case. The problems that it encounters, the fact that it's completed a task is going to be really interesting because that's when I need to use its output. Either expect the shirt in the mail, or in the case of the Roomba, it's saying, hey, I'm done cleaning your floors. You need to come empty out that little tray at the back. And any routines that it's going to be undergoing. Hey, in the future, here is what's coming up. I don't think any of those is a surprise. The do, though, on an agent is kind of surprising. Not surprising. New use cases that we have to take account of. The first is telling the agent, calm down, I'm going to play for a little while. Last night at a movie night, we showed Guardians of the Galaxy, and there's a great scene where Rocket the raccoon is looking for a mark that he and Groot can kidnap and make a lot of money with. I mean, to do that, he's got this little heads-up display that he's putting over people's faces, and he's watching a little reticle and some side information to tell him what the value of that particular mark is. He puts that device down and then addresses Groot, who's drinking out of a fountain. And then it beeps at him, and it says, beep, beep, beep. He picks the thing up. He finds Peter Quill, and he's like, whoa, we stand to make a lot of money with this guy. And that little beep is really telling because it's saying that this device has been looking for the mark all along. So why was Rocket picking it up and playing with it? Because it fits his personality. He wants to be able to take over and play and try and beat the algorithm to figure out something that it doesn't quite know. So that use case is going to be pretty critical. Correcting a rule when it gets something wrong. Naming an exception to say, OK, I see why you thought that was right, agent, but let me tell you why it's wrong. And then graceful degradation. We have our keynote tomorrow that's talking about self-driving cars. And that's going to be a case where the graceful degradation of the system is going to be pretty vital. Not just in the trolley car case example where the car has to pick between who am I going to strike, but OK, what about it when the algorithm breaks down on the car? How do we not cause a massive pileup? How do we actually get those people either safe or to their destination? And I have some ideas about that, but the point is we have to do the useful the graceful degradation so that when agents fail, humans are not failed as a result. So those are all big and kind of new agent problems. And they lead us to certain issues that we're also going to have to resolve. In the case of graceful degradation and the self-driving car, if you've been in that car for 5 years and you've never had to drive, what happens when the car tells you you suddenly need to drive? Pilots face this with their autopilot. Oftentimes they get a little bit bored on flights, but suddenly the plane is diving. You need to take control of this thing. So booting up the human in those circumstances is a strange new use case that will involve just-in-time training and lots of fast information. Natural user interfaces, massive interest in, especially in the interaction design world right now, and they will play in really strongly to agents because the more naturally you can communicate with them, the more humane they will seem. There are also issues about anthropomorphism. How do we actually embody these agents? We don't want Clippies in the world, but how do we get close? There are issues like digital paralinguistics where we're going to have to say, okay, how do I know that it's listening to me in the real time? And finally, there's like information versus privacy. If the agent is watching all of my social media or has a camera on the front of the Nest, how do you balance that thing of, oh, I'm taking a look at your entire life? How do we balance the information that it gets from the privacy that I may want from that agent? If you're interested in this model, my talk tomorrow will be taking this model and applying it not only to the narrative camera, so that we look at its interface, but also to the intelligent portfolio that I mentioned earlier. But for now, just take a look at that model and understand that I think we have a pretty good model that is just an extension of existing ones in order to design agents. Okay, with 5 minutes left, where are we? Most of the attention at artificial intelligence is focused right here, right now. People are terrified. Bill Gates famously said, oh, first they're going to be fine. And interestingly for me, that first part of that phrase is actually about agentive technology. But he said a few decades after that, the intelligence will be strong enough to be a concern. Elon Musk famously said that it is our biggest existential threat. Even Wozniak joined the boat to say that it's an existential threat and we have to be very wary of it. And even Stephen Hawking, another luminary who joined the fray of big thinkers who were terrified of the AI. And in fact, tomorrow, our closing keynote speaker is Tim from Wait But Why. He's going to be talking about strong artificial intelligence or superintelligence as well. So there are a lot of smart people who are really concerned about this side of the artificial intelligence equation. But it's my assertion that if we get the agentive part right, all of that road that leads up to general and artificial intelligence will be really well set up, right? Agents are the natural evolution of user-centered technology. If you're trying to do the most for people and have them do the least work to get it, agents are the natural thing to get to. I believe that they are distinct and warrant a focused community of practice. And that's partially my call to action, both with this talk, if you're interested in this sort of thing, like let's continue the conversation and get good at this. But finally, to address the concerns of those who are super concerned about superintelligence, I believe that if we get it right, we'll have several decades of good rules to hand to the superintelligences, to say, here are the rules by which you can treat us well. It will be a care and feeding manual for those terrifying future overlords. If you're interested in more on this, this is all thoughts that I have towards a book, and again, a call to create a community of practice around people who are designing or developing agents. You can join that conversation. I've got a Twitter stream started at Agentive Tech, and I am on schedule to get a book published with Rosenfeld Media of next year, possibly under this title, but certainly under my name. And we're swinging in right under the 40-minute mark, so thank you very much.